the Taylor series for cosine x centered at a equals pi. And we know that the Taylor series is given by, for a function fx, is sum n from 0 through infinity cn x minus a raised to n, where a is the center. And these cn's, we need to determine cn's, they are found using this formula. Cn equals nth derivative of the function evaluated at the center divided by n factorial. Okay, so all we have to do is find the constants c0, c1, c2, etc. For we start with the function is cosine x. Let's evaluate at the center of at pi. That means cosine pi, which is -1. Okay, from this we get c0 is -1 over 0 factorial, which is 1, so just -1. So this is for n equals 0, so we got c0. So we do for n equals 1, n equals 2, n equals 3, n equals 4, and so on. For n equals 1, that means we are trying to find c1, so we find the first derivative. Derivative of cosine is negative sine x, so evaluate at the center pi, negative sine pi, -0, which is 0. So c1 is 0 over 1 factorial, just 0. For c2, let's find the derivative, that's negative cosine x, evaluate at the center. So negative cosine pi is -1, negative of -1 is +1. That gives c2 equals 1 over 2 factorial. Okay, and let's find the third derivative, minus derivative of cosine is negative sine, so this becomes just sine x. Let's evaluate third derivative at center, so sine pi, which is 0. So c3 is in fact 0 over 3 factorial, just 0. Let's find the fourth derivative. Derivative of sine is cosine x, so we are back here. So when we evaluate the fourth derivative, so we get -1 because cosine pi is -1. That means c fourth is -1 over 4 factorial. Now if we go for finding fifth derivative and find c5, that will be 0 because will be here, 0 over 5 factorial, 0. And c6 will be here, so 1 over 6 factorial. And c7 here, that would be 0. c8 will be -1 over 8 factorial, etc. Thus, let's write the Taylor series for cosine x, our function. Cosine x is, here's the formula. Now I want to write this in the expanded form. That means when we expand this, we get c0 x minus a raised to 0, that's 1, c0 plus c1 x minus a is pi, plus c2 x minus pi squared, plus c3 x minus pi cubed, plus c4 x minus pi raised to 4th, etc. Which is c0 we found that to be -1, c1 is 0, c2 is 1 over 2 factorial x minus pi squared, plus c3 is 0, c4 is -1 over 4 factorial x minus pi raised to 4. Okay, and we have c5 now. c5 is 0, c6, that's 1 over 6 factorial x minus pi to the 6th. We did not have that, but we would get this, plus etc. Okay, if we just write down non-zero terms, so -1 plus 1 over 2 factorial x minus pi squared minus 1 over 4 factorial x minus pi to the fourth plus 1 over 6 factorial x minus pi to the sixth. The next would be plus minus 1 over 8 factorial x minus pi to the eighth. You don't have to write everything, but if we write more terms, then we can easily write down this n equals 0 through or 1 through infinity. Okay, we need to write the closed form. So we are getting negative, positive, negative, positive. So negative 1 to the n. If we start with 0, then n plus 1. So when n equals 0, negative 1 raised to 1, which gives negative. Okay, and 2, some power 2, 2 factorial. This is 0 factorial, 4, 4 factorial, 6, 6 factorial. So these powers are just multiples of 2. So 2n. So this should be 1 over same thing, 2, 4, 6, 8. Those are just multiples of 2. 2n factorial x minus pi raised to 2n. When n equals 0, we get 0 factorial, something raised to 0, that's 1. And here we get 0 plus 1, just 1. Negative 1 raised to 1 is negative 1, very first. When n equals 2, we get the second term. 2 factorial x minus pi raised to 2. So this is the power series for cosine x centered at pi.